Hello everyone. In this video, we will find the coordinate of the centroid of the area considered as thin flat plate with constant density bounded by the two following parabolas. Okay, so this video is a continuance with the previous video. So let me go back to show everyone what I've done with the previous video. So in previous video, I actually went over how to get to the formulas to find the centroid of a thin plate represented by the area is the x bar and the y bar for the coordinate. Okay, so my is derived as this integration, and the area is this formula of the upper function minus the lower function, and we are using the vertical element in this case. So for the y bar, the area formulas is still the same, but for the numerators, or to find mx, we are going to work with these formulas: a half integral from a to b, y2 square minus y1 square, and we integrate in terms of dx, which is the vertical element as well. So there are three steps in calculating the centroid of an area. Okay, so in previous video we did this. We try to derive the formulas for x bar, and then we identify that we are going to use these formulas to figure out y bar because we want to be consistent using just the vertical element. Okay, so for this particular example, so the first thing I'm going to do is I'm going to find the areas. Okay, so I'm going to find the area first. And using the vertical element, I have to identify the upper function and the lower function. So in order for us to identify the upper and the lower function, you need to put your eyes within the area that you are working with. So that's why we shade the area in, and then we only look within here. But you look outside, okay, it seems to be the upper and the lower function kind of messed up in this case. But you are finding the area, so therefore you need to shade it in. Within here, you can see that the parabolas open down is the upper function. The parabola opens up is the lower function. Okay, so you look outside, you can see that you tend to think that this parabola is the upper function and this parabola is the lower function, which is incorrect. So we need to shade the area in, identify the element that we are going to use, which is the vertical element. Okay, so y2 is the upper function, and it's a parabola open down because you are having the negative in front of x squared. Okay, so the value for a is a -1, therefore this parabola opens down, and this one is parabola open up. So it's a good idea to identify it and write y2 and y1 before we use the formulas to work with. Okay, so before I continue, I would like to show everyone that I have create a document summarize everything for this particular unit. Alright, okay, so we have a definite integral, or that we have to apply the fundamental theorem, and the area between the curves. Okay, area between the curves. So we are concentrating on these formulas right here, and then to find centroid, we are going to use these formulas because centroid of an area. Okay, of a thin plate represented by an area, and you can use these formulas to work with. And there are three steps. Obviously, we need to find the area, then we have to find my, then we have to find mx. Okay, and divide the area into my to find x bar, divide the area into the mx to find the y bar. So we need to find area, mx, and my. Alright, so let's get back to our question. So it's not complicated, it's just tedious and a lot of algebra. Okay, so I know that I need to apply the formulas to find the area, so I'm going to write that down for everyone. So the area is equal to the integral from a to b of y2 minus y1 and dx. Okay, so I need to find the point A and point B. So right here, project it on here, I should have A, and right here I should have B. A, B's are the point of intersection of these two functions. So I'm going to let 2x minus x squared equal to x squared minus 4. Let the two functions equal to each other. Then from here, I can solve for the values for x. So now you see that you are working with a quadratic equations in this case. So I'm going to move everything to one side of the equation. Quadratic equation, I need to have one side equal to 0. So I'm going to move everything over to the side so that I can have a positive value for x to work with. Okay, so x squared plus x squared minus 2x minus 4. All right, okay. So then I will have 2x squared minus 2x minus 4. So now at this point, what I have is, because of a quadratic equation, and this side equal to 0, I can simplify by divide everything by 2. So I divide this by 2. So you can only do this step, simplify your equation, because you have a quadratic equation and this side is equal to 0. Okay, so then this equal to 0, I will have x squared minus x minus 2. And from here, I know that I can solve for this quadratic by just factoring. So I factor this out, I should have x minus 2, x plus 1. Therefore, my two solution will be x equal to 2 and x equal to minus 1. All right, okay. So how about I do step by step. Okay. So I will have x minus 2 equal to 1. Therefore, x equal to 2. Or x plus 1 equal to 0. Therefore, x is equal to minus 1. So the points on here is the minus 1 and then the 2. Okay, so now the next step is to find y2 minus y1. Okay, so y2 minus y1 is equal to 2x minus x squared, subtract y1 x squared minus 4 in the bracket. So y2 minus y1 equal to 2x subtract x squared, subtract x squared plus 4. So then my y2 minus y1 equal to 2x minus 2x squared plus 4. Okay, so I would like to pause here 1 second, and I want to remind everyone of this. Okay, so at this point, you are working with y2 minus y1, and this is not equal to 0. This is the integrand that you have to integrate. Okay, so and in this case, please do not think that there's a 2, there's 2 and the 4. It's so easy to divide it by 2. And in this case, if you find the area, you actually just find only half of that area. So don't do that. Make sure that you keep all the integrand the way it is. So area will be equal to the integral from minus 1 to 2 of 2x minus 2x squared plus 4 dx. Okay, and all the steps that we have done up here, and which I'm going to put it into a big clown here to show everyone that we only did all of this stuff in order for us to find the upper and the lower limit. Okay, and integrating this, I should have area equal to, integral of 2x is 2x squared divided by 2. Integral of 2x squared is 2x cubed divided by 3. Integral of 4 is 4x. Identify, evaluate from negative 2 to 2. So I will have to find f2 minus f of minus 1. Alright, okay. So I will do step by step. So area equal to, I will have, this one will be 2. Okay, so 2 square will be x squared. Subtract 2 over 3 times 2 to the exponent 3. Subtract 4 times 2 and close the bracket. Subtract this with minus 1 square. Minus 2/3 times minus 1 to the exponent 3 plus 4 times minus 1. Close the bracket. So this is my f of 2 and this is my f of minus 1. Okay, so now area, if you find this, it will be equal to 20 over 3. And I subtract with this. Alright, okay. So I would like everyone to consider. So this one is a negative 1 square, so it's a positive 1. So this one will be a negative to the exponent 3, so it will be a negative 1. So basically, what I have here is I should have positive 1 and plus 2/3 and minus 4. So doing this, I should have this one equal to minus 7 over 3. So I will have 20 over 3 plus 7 over 3. So it will be, the 7 over 3 is 20 over 3, so it's 9. So it's a 9 unit square. So we find the area as 9 unit square. Okay, so minus 1 plus, just let me double check this part right here. Okay, yeah. So after we finish the area, we will leave it aside for now. And the next step is to find my. Alright, to find my. My is equal to the integral from a to b of x multiplied by y2 minus y1. And all of this integrates as a function of x. Okay, so remember here that I mentioned to everyone this is so important. Okay, so y2 minus y1 is already figured out for us right here, right? And do not try to simplify this because it will affect your next part of the calculation as well. So I don't want the simple mistake here will lead to many other error later on. Okay, so in this case, I will have x multiplied by, so I will write my, the integral from negative 1 to 2 of x, and I multiply y2 minus y1. Okay, so make sure that I got it correct. 2x minus 2x squared plus 4, and all of this multiply inside the bracket first before we integrate. So the integral minus 1 to 2 of will be 2x squared subtract 2x cubed plus 4x, all of this as dx. So this will be equal to 2/3 of x to the exponent 3 minus 2 over 4 x to the exponent 4 plus 4 over 2x squared. Okay, I simplify in a minute. Just want to make sure that we do step by step. Okay, so now my equal to 2/3 of x cubed subtract a half of x to the 4 plus 2x squared. And we are going to evaluate from negative 1 to 2 by 2 f2 subtract f of minus 1 in this case. Alright, okay. So let's figure that out. So my will be equal to, okay, so this is 2/3 times 2 to the exponent 3 subtract a half times 2 to the exponent 4 subtract 2 times 2 to the exponent 2, close the bracket, subtract this again, 2/3, but then this time I replace x by negative 1. Okay, so I will do a quick calculation here. I will let you do all the that and that. I should have 16 over 3. Okay, subtract 5 over 6. So that will give me 9 over 2. Okay, negative 1q minus a half, negative 1 to the exponent 4. So this should be a positive value. Okay, so I think everyone can figure that out. So now I'm going to write x bar equal to my divided by area, right? So my is 9 over 2. I divided by the area, which is 9. Okay, so 9 over 2 times 1 over 9 will give us a half. All right. Okay, so we are going to make a note that x bar is equal to a half. Okay, so next step is we are going to find the mx, and finding the mx is using the half integral from a to b of y2 square subtract y1 square as a function of x. Okay, so we are going to use these formulas so that we just have to work with the vertical element. All right. Okay, so let's find y2 square. So y2 square is equal to, I just want to see if I give myself more space. Yeah, I don't think I did, so I better, so what I'm going to do is I'm going to rewrite this on this page so I will have more space to work with. Okay, so, so this should be mx half integral from a to b y2 square subtract y1 square and then dx. Excuse me, sorry. Okay, so let's use all the space that we have. So y2 square equal to, okay, I'm going to write it here. So y2 square will be equal to 2x subtract x square, all of it square. And then I'm going to square this, but I will use a shortcut and I just use these formulas. Alright, so I just want to remind everyone that a plus b, or a minus b in this case, will be equal to a squared subtract 2ab plus b squared. Okay, I want everyone to use that formulas, the special product. Okay, so or if you don't want to use that, you can just go ahead and expand. But in this lesson, I just want to use this to shorten the time. So in this case, I should have 4 x cubed plus x to the 4. And my y1 square will be equal to x squared minus 4, all of it square. So I should have x to the 4. Okay, subtract 8x squared plus 16. All right, now my y2 square minus my y1 square will be equal to 4x squared subtract 4x cubed plus x to the exponent 4. Let's subtract this in the bracket. Okay, so this in the bracket. Make sure that we are going to consider the distributor, this term, minus 16. All right, then we have that cancel out and combine like term to see what we get. Okay, so I should have 12x squared. I should have negative 4x to the exponent 3, and I should have negative 16 because these two terms I already combined. Alright, okay, so we double check before we start integrating, or else one little error will lead to the other error. Okay, So now I'm going to write down mx equal to the half of negative 1 to 2 of 12x squared subtract 4x to the exponent 3 subtract 16 and dx. Okay, so now it's going to be a half integral minus 1 to 2, and then what you want to do in this case is to simplify. You can see that now you have 12, 4, and 16. Why don't we factor out the 4? Okay, so let me correct this. So I factor out the 4. Inside I should have 3x squared minus x to the exponent 3 minus 4 dx. Okay, now 4 is a constant. I can bring this across the integral sign because I know that I can simplify the 4 with this a half. Okay, so I bring it across the integral sign. Okay, so this cancel with that, right? So I should have just a half left. Okay, now so I mean 2. 4 divided by 2 is 2. I'm sorry. Okay, so this is 2. And then the integral, I'm going to figure that out right now. So it will be 3 over 3 x squared plus 1, which is 3. So x to the exponent 2. I take 2 plus 1, become a 3 divided by the 3. And this should be negative 1 over 4 x to the exponent 4 minus 4x. Alright, okay. Evaluate from negative 1 to 2. Apply fundamental theorem of calculus and close the bracket. Okay, so one thing I would like to remind everyone is you don't want to rush. I feel like I'm rushing here, and then I I tend to make error when I rush. So that's why I'm asking everyone, just do not rush. Okay, so I can see that I just have like 8 minutes left, so I think I do have enough time to complete this example for everyone. So now, so let me leave the 2 outside the bracket for now, and I'm going to calculate my f2 and my f of minus 1. So in this case I should have, okay, 3 divided by 3 is 1. So substitute 2, I should have 2 to the exponent 3 and minus a quarter of 2 raised to the exponent 4. Subtract 4 times 2. Okay, and I subtract this with like minus 1 to the exponent 3 minus 1 over 4 to the negative 1 to the exponent 4 minus 4 times minus 1, close the bracket. Okay, so checking everything. So this should be my f of 2. This should be my f of minus 1. So minus 1 cube, that, minus 1 to the exponent 4, 4 minus 1, and mx is equal to 2. And this part here is in fact equal to minus 4. And this part here in fact equal to 11 over 4. Okay, I will let you use your calculator and figure this out. And now the inside the bracket should become negative 27 over 4. Okay, so now I should have this as negative 27 over 2. Cancel that. Now, so don't forget to conclude the y. Okay, so now you should have y bar equal to the mx divided by area. So mx is negative 27 over 2. You divide it by 9, right? So it's negative 27 over 2 times 1 over 9. So I should have negative 3 over 2. Because that and that should give me negative 3. All right. Okay. So don't forget another conclusion here. Okay. The centroid x bar y bar is equal to the 1/2 and -3/2. Okay. So I have about 5 minutes left. So let me go over what we have done. All right. Okay. So make a quick summary of what we have done. Okay. For this example, finding the centroid for this particular area, consider a thin flat plate, okay, with a constant density, okay. Then bounded by these two functions, the very first step is to find the area. And using integration, after we find the area, we are going to leave it aside because that will be our denominators now, okay? So you divide this area into your mx and your my. The next step is to find your my. To find my is this formulas. So we are going to take x times y2 minus y1. y2 minus y1 is very important. It's in this square that I identify here. That please do not try to simplify this because this is not an equation equal to 0 or anything. This is the expression that you have to find. So you have to leave all the terms the way they are. Okay. So we integrate that. Apply fundamental theorem. We got that equal to 9/2. And then after we got 9/2, we make sure we divide it by the 9. Then we have x bar equal to 1/2. And then we are going to use these formulas to find mx, the 1/2, so that we can find the numerator for y bar. Okay, so 1/2, y2 square, subtract y1 square, the vertical element as well. And then we are going to use our algebra skill. Okay, so this is very important. And you can expand this by just multiply this function twice, or they call FOIL, but I just use these formulas, the special product, a minus b squared equal to a squared minus 2ab plus b squared. So doing this, I can just summarize it into 3 terms right away, okay? So, but if you expand, it should be the same. So it's 4x squared minus 4x to the exponent 3 plus x to the exponent 4. This one I should have x to the 4, subtract a x squared plus 16. So subtract the two functions. Make sure that you put this part inside the brackets so you can distribute. And then double check our 3 terms because we have to integrate one more time using this 3 term. And then for this 3 term, I can see that I have the common factor of 4. So I factor it out. So I bring it across the integral sign. I cancel this. I take 4 divided by 2, or I take 4 times the half, should be 2. And integrate this. And I should have this, yes. And evaluate the definite integral. Apply fundamental theorem of calculus, have f2, f minus 1, and I will let you use your calculator to figure out these values. All right, okay. So I should have -4, -11, subtract positive in here, 11/4, and then I have -27/2 as mx. Don't forget to divide by the area equal to 9. That means you multiply by 1/9, and the ordinate become -3/2. So make a conclusion for me, please. With the conclusion is the y bar x bar is equal to this coordinate. Okay, so I have a few questions that I would like everyone to try, and please make sure that you work with this. Do some practice. I have quite a few questions here, and I kind of laid out for everyone that you have to find area, centroid, and then in the end you conclude. All right, I have only 2 questions for everyone to work on, and I give you plenty of space. So, all right, thank you.